Hi, I'm Eric Bogatin with BeTheSignal.com, reporting for Real Time with IPC. And joining me today are Kathy Jenczewski from Microscreen and Bill Coleman from Stencil. And Bill and Kathy are co-chairs of the 5-21E committee, the Stencil Design Task Force. Could you tell us a little bit about what the purpose of the task force is and what you're working on?
Yes, our committee was formed in late 1990, and it's made up of stencil manufacturers, screen printer manufacturers, solder paste people, and most importantly, users of stencils. And we have put together stencil design guidelines so people that are going to be using stencils have an idea of some of the general guidelines. Our first document was published in 2002, and then we issued 75-25A in February of 2007.
So you're in the second rev of the document right now. And what sort of features or design guidelines do you actually cover? Is it just in the stencil design?
Pretty much in the stencil design. There's a lot of things that go as far as the stencil's performance, the stencil thickness, the aperture design for the various different components. For example, we cover step stencils, stencils that have a relief pocket in case there's anything that happens to be protruding on the surface of the board, and different stencil technologies, chemical etch, laser cut, electroform stencils are all included in this document. Also, we look at different devices like BGAs, micro BGAs, and some of the smaller QFN devices.
And are you finding that there's a transition or change you have to make when you go from standard leaded solders to lead-free pastes?
Yeah, that's the main driving force, I guess, right, Kathy, for us doing the Rev A was we had to address what happens when people go to lead-free. Some of the aperture designs change, and so forth. So,
is it an increase or decrease in the aperture size with lead-free?
Pretty much what you want to do with lead-free is keep the aperture size close to the pad size, because the lead-free just does not flow necessarily as well as a tin lead solder paste.
And do you cover in the document some of the tricks of the trade in order to get successful assembly of some of the new small parts?
Well, basically, we are guidelines, so we're trying to make the document as general as possible so that depending on your stencil manufacturer or your printer manufacturer, the paste, you're not locked in. So it is basically guidelines.
What do you find as the most challenging kind of parts to have to design the stencil for, where the design of the stencil really makes a big impact?
Certainly some of the finer pitch devices like the 0201s, and now the 01005, which wasn't necessarily included in the document, so that's why we're having a meeting next fall to try to get the task group together again to address that, as well as the 0.3 millimeter pitch micro BGA. All of those definitely offer a challenge to the stencil. And one of the things that we did in the Rev A guideline was we had what we call an area ratio calculator, but it was more or less put into a spreadsheet. I think what we're going to try to incorporate in Rev B would be something that's electronic, where people can put the aperture size in, the stencil thickness, and it'll tell if this design is really going to work or not.
I find it incredible that we're assembling these 0201s and the 01005 parts. I mean, to do a stencil for these kinds of parts, what's special about, what do you have to do with the stencil? How do you make that stencil?
Well, it all depends on the area ratio, and certainly for a 01005 part, the part is 5 mils wide and 10 mils long. So your stencil apertures have to be very small. In order to get good paste release, that means your stencil is going to have to be thin. So the challenge that the assembler faces, how do I print my normal stuff in these very small apertures at the same time? So some people are looking at step stencils. We're actually presenting a paper at Apex this year that uses a different approach. And basically you print the 01005s and the 0.3 micro BGAs with a very thin stencil, maybe a 2 or 3 mil thick stencils. Then you come back with a second stencil, which has a relief pocket etched in it,
wow.
where that paste is, and you can print your RF shields, your surface mount connectors for batteries and so forth, with a stencil which is 5 or 6 mils thick. So that's sort of a different approach to try to solve this problem.
Wow. And then for the kind of intermediate range, but the small packages like the QFNs, the small, I think they're called bottom terminal packages, what are the challenges there that you have to deal with?
Pretty much the challenge is to keep that small package from floating when you reflow. So one of the design guidelines we put in here is basically to reduce the aperture size for the ground plane by almost 50%. And basically what we do is create like a window pane aperture, so that now when the solder paste melts, it has room to basically outgas, so it doesn't twist and turn the QFN part during reflow.
So you have guidelines then for the stencil design for the parts that have the leads as well as the large copper slugs on the bottom.
Correct.
And for the other end of the technology, the traditional off-the-shelf kind of large BJs, 50 mil center kind of thing, is that pretty straightforward? Is that a pretty well-established technology? Or is there anything
Pretty
new
much
in that?
it is, and that's also addressed in here. One of the interesting things that's coming about is wafer level processing, where people are actually doing ball placement at the wafer level, and they also require both flux stencils and what we call ball drop stencils. So in our next meeting, we want to try to get some of the semiconductor people involved in this also, and try to come up with some guidelines in that area.
Great. And if someone wanted more information about what your committee is doing, where's the best place to go?
To the IPC website, which would be www.ipc.org.
Great. Well, that's all the time we have for today. Thank you very much, Kathy and Bill. This is Eric Bogatin of BeTheSignal.com reporting with real time for IPC.